Okay, folks, today we are going to multiply and divide monomials. Our essential question is, how can I simplify a real number expression by multiplying and dividing monomials? So the very first thing that we probably should do here is just define that term monomial. All right, it is a number, a variable, or a product of a number and one or more variables. So a number, 3, a variable, x, or a product, 3 times x, of a number and one or more variables. X, maybe it's 3xy. That is an example of a monomial. Okay? It might just be a number by itself. It might be a number that has an exponent connected to it. Okay? So we're looking here today to how can I simplify expressions multiplying and dividing. So let's start with multiplying, and this is called using product of powers. So I'm going to take a base number 3, and I'm going to give it the exponent 2. All right, so 3 is the base, 2 is the exponent, and I'm going to multiply that by 3 to the 4th power. Okay, 3 to the 2nd power is 9, 3 to the 4th power is 81, so I'm going 9 times 81 to get my answer. Instead of doing all of that, I can simplify this. Because 3 to the 2nd power really is 3 times 3. And 3 to the 4th power really is 3 times 3 times 3 times 3. And I was multiplying in between these. So an easier way to write this, in my opinion, will be 3 to the 6th power. And now all I would have to do is punch that into my calculator. So my little rule here. When multiplying monomials with the same base, it's got to be the same base. It's got to be a 3 and a 3 or whatever I'm working with. It can't be a 3 and a 2, then these rules won't work. With the same base, I will keep the base the same. And add the exponents. So if we looked at this a little bit further, we do another example here. Example 1, we'll call this not A, because that's A. X to the 3rd times x to the 5th. Our base, the number that's holding the exponent, is x. It's multiplication, so we're going to add our exponents together to give ourselves x to the 8th. 2. If I give you 5 squared times 5, the base is the same, so we know we're going to keep that the same. I'm going to add my exponents together. Well, this is a 2. There's not one here, so that's really a 1. So this turns into 5 cubed. And then I could evaluate that. When I evaluate that, I could either go 5 times 5 times 5 in my calculator, or I go 5 caret, which is creating the exponent value. I hit 3, and that would give me 125. But we're only worried about writing it with an exponent and a base. The third example, a little bit tricky. -3 x squared times 4x to the 5th. Now, my base is just the number that is holding that exponent. So that's just the x. These, the -3 and the 4, those are just coefficients. So we have to add another rule here for our product of powers. This is going to tell us to just multiply the coefficients. So my x's stays the same. Keep the base the same. It's just going to be x. Add my exponents. 2 and 5 is 7. So then I'm going to multiply my coefficients, -3 and 4, to give myself -12. Whoops, got to really squeeze that in. -12x to the 7th. So that is how we work with product of powers. But we also have quotient of powers. So let's say I give you 5 to the 7th over 5 to the 4th. 5 to the 7th is in exponential form. If I write that out in expanded form, that really is 5 times 5 times 5 times 5 times 5 times 5 times 5. I think it's 1, 2, 3, 4, 5, 6. Yep, it's all of them. And 5 to the 4th in exponential form turns into 5 times 5 times 5 times 5 in expanded form. Now, if I look at this in terms of quotient or dividing, I can kind of cancel out. Cancel, 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 cancel. I'm left with that guy, and that guy, which really is just 5 to the 3rd power. Instead of writing all that out in expanded form and crossing stuff out, we have some more rules. Rule C. When dividing, keep the base the same. And now we're going to subtract the exponents. So, example 4. 4 squared over 4 to the 8th. My base is the 4, and that stays the same. I go in order and subtract. 2 minus 8, and that's 4 to the -6th. That's okay. You can have a negative exponent for right now. We'll learn some more rules on how we should change that eventually. Example 5, -12x to the 5th over 2x squared. Here, like before, our x is the base. These are just coefficients out in front. So let's add a rule here where we divide the coefficients. So x stays the same. I don't change that. I go 5 minus 2, and that gives me 3. And then I have to go -12 divided by 2 to give myself a -6. Sometimes people get these two mixed up. You'll subtract here, and that'll impact your answer, and you'll write it as like -10x to the 3rd. Avoid that. Avoid those types of mistakes. If you have any questions, let me know.